Okay, so good morning, everybody. It is a pleasure today to have with us Petra Galuščáková. She is an associate professor at the University of Stavanger in Norway, and she works at the intersection of information retrieval and natural language processing. She did her PhD at Charles University in Prague, and she then was a postdoc researcher at the University of Maryland and at the University of Grenoble Alpes in France. Her primary research concentrates on providing robust access strategies for complex search scenarios, such as cross-language retrieval and speech retrieval, and on leveraging multiple diverse models for problems with a high degree of uncertainty. So today, Petra will talk us about evaluating temporal persistence for information retrieval models, which is basically what the LongEval lab is doing in CLEF 24. So Petra, thank you very much. And
yes, thank you very much for introduction and also for the invitation. Yes, as said, I would like to introduce the LongEval lab today. And can you see the presentation now? Okay. So I would first like to go through the task in general and introduce the problem a little bit. Then I would like to go through some more practical information about the collection and how to participate in this. I would also like to introduce a few ideas of like what worked and maybe didn't work in last year or last edition of this track, and based on that, like give some ideas on maybe what can you try out in this year. And also I would like to look at the manual assessments of the relevance, which we are also trying to do. So the problem looks like this. So we are cooperating with the search engine company Qwant, which is a French search engine company, and they are focusing on the privacy of the users. And they have a collection of the web documents downloaded and indexed, and then there are users of the collection. So these are just people who are trying to use the search engine, and they are typing in the queries, and we are trying to return the relevant websites to them. So what's the problem in this kind of scenario, but also it's a problem for many different information retrieval systems, is that the collection is somehow evolving during the time. So if you take the most searched queries on the March 20 in France, these are all regarding some kind of protests which were going on during the day or day before. So at least like 3 different queries from the top 5 were somehow related to these protests. But when you look at the most frequently searched queries on very next day, on March 21st, there are like nothing about the protests, so the queries look very differently. So what people are searching for is evolving very quickly, and also the documents in which we would like to search are evolving. So on March 20, we would ideally like to be able to also provide the users the news from the media. So we would like to index the documents from the different news sites and enable users to search also in very hot topics. But this also like changes every day. So there are different kind of changes with which the information retrieval systems needs to deal with. So one example of the change is the trends in the topics. So this might be like they are searching for protests on March 20, and then maybe about some events and concerts on March 21st. Then there are like different changes in the documents. So documents in the collections the new documents need to be indexed. Some of the documents which are outdated should be maybe removed from the index. And also even the content of some documents is changing. So even if you have the same document, it might contain like dynamic content, and this is changing also maybe from day to day or from week to week. And also what people assume as relevant is changing over the time. So when you are searching for the news in 2020 or 2021, then things about COVID were relevant. But now if you are searching for the news, maybe your general interests are very, very different. And this is of course moreover subjective for different users. So there are many things which are like changing in the information retrieval system with which we should somehow deal with. Just an example, so let's say that we are just changing the documents and we are adding new documents to the index each month, and we are removing the old documents from the index. So that's the case of the robust collection. So robust is one of the most classical information retrieval test collections, and it contains of some news data which were produced during several years. And if we take just the oldest documents of the collection, so that's this case, we take the 1/5 of the collection, which is the oldest, and then we are adding the documents which are newer, and we are removing the documents which are older. So this contains only the latest documents, which are still from 1994. Then you can see that the map score actually changes quite a lot. So it changes from 0.20 to 0.30, and just depends on at which time point did you work with the collection. And this is just a general remark that the vocabulary in the collections is also changing quite a lot. So here you can see, so this is not information retrieval task, but I think this is some kind of like classical text classification task. And these are different collections, and you can just see the vocabulary over the years. So the words which are used over all the years are, I think, in green. The words which are used over some of the years or in the several like subsequent years are in brown. And the words which are actually unique for different years are these gray. So we can see that the amount of the words which are very unique for different time periods is like, especially in this collection, it's huge. And this, of course, affects especially the neural information retrieval systems, because they are trained at some timestamp. And whenever then you shift from this time point, then the performance of your system drops. So here you can see again, this is the classification task, but you can see that the system was trained at the time 0, and the -1 to 3 and +1 to 3 are different years which occurred before or after this time 0. So you can see that the performance of the system is dropping quite rapidly. So in LongEval-Retrieval, we are trying to deal with these kind of problems. We are trying to answer questions like how do the search engines behave if the collection behaves, what kind of information retrieval systems are more robust against different kind of changes in the collection, and while they are still performing well, ideally. And we would also like to know like when and how to update information retrieval systems when the collection evolves. So therefore we built this kind of collection which contains of several sub-collections. This year we are using the documents and logs from the users from Qwant which were collected during 2023. And we are having a train collection which was collected during January. And then we are having 2 test collections which were collected during June and August. So in June there was like 5 months difference from the training data, so we call it lag 5. And in August it was a 7 months difference since the training data were released, so we call it lag 7. And the collection is collected or created in the same way during all these months. So the way how the collection was collected is the same, but we think, or we assume that the documents and queries are evolving across this time. So this should reflect the changes on the web and web searches across the time. And we would like to now see the differences between the training data and the test data, and also within the test data by themselves. Just a note, so in LongEval we are having 2 tasks. I'm just explaining the LongEval-Retrieval subtask at the moment, but there is also a classification task which works with the sentiment analysis and with tweet data. And these tweet data are collected over several years, and they are labeled as positive and negative. And the main task is the same, so we are having the training data collected several years before, and we would like to see whether there is some kind of drop when the test data are collected afterwards. So you are also, of course, welcome to participate in the classification task. So regarding the collection, it was created like this. So we started with the topics. So topics is something like a very general description of some area, and based on that we collected some queries from the query logs. So the queries are somehow related to the topics. Topics are not changing over the time frame, so the topics are the same for January, then June, and then August, but the queries are changing. So we are collecting the different queries for each of these months, and based on the queries we are collecting the documents. So we are collecting the documents which were displayed to the users of the web search engine. And we are also adding some more documents to make pretty much the task harder for the participants. So I will go through this in detail, but if you are interested in the more details about the collection, we are also having the paper which was released on CGIAR last year, so it contains more details about the process. So for the topics, these are like very general ideas, and we try to get some diverse topics which are also somehow stable and general across the time. So here are like just examples of the topics with their translation. So it's like something like money, cars, food, police, energy. Queries were created so that they are related to one or more topics. So these are somehow multi-word chains, which should also contain the topic word. And these are unique for each sub-collection. So the topics are not changing, but the queries are changing for each sub-collection. And they are coming from the query logs from Qwant. So these are the real queries which people were asking in the search engine. As the Qwant is a French search engine, so we would like to also enable the people from which are not French speakers to be able to work easily with the data. So we also provide the English translations of all of the data in the collection of both queries and documents. For this, we are using the translation system from Charles University in Prague, and you can assume that the translations of the quality of the translation of the documents can be like much higher than the quality of the translation of the queries. And that's why we also tried in this year to provide multiple translations of the queries. So queries are usually much shorter, they don't contain any context. So this year we aimed to have multiple translations for each query. So this is an example of that. And you can see these are the original French queries. There is, for example, this query chapeau, and the different translations are ahead and achieve, and there is actually also the possibility that this is some kind of name, so we just use it as it is, so it's a chapeau. Some of the translations are actually the same. Some of them differ in a very small way. So, for example, only these two only differ in the capitalization, and these are, so this is like more complex query. So these are different. These are different translation of the phrase. And they differ here in what is the use of the land grab and what is the purpose of the land grab. So sometimes the differences are quite large, especially for these short queries. They can be like very different. If it's a longer phrase, then sometimes the differences are quite small. But you're allowed to use all of these translations, but you can also stick to just one or just few of them. For the relevance assessments, these relevance assessments are created automatically based on the clicks from the users. We are not using the raw clicks because these are very noisy and biased. So, for example, they would depend on like the position of the document in the results. So therefore, we are creating the relevance assessments using the click model. So we first create a model based on the real clicks of the users, and then we use this model to create the relevance assessments. And also this is better for preserving the privacy of the users, so we are not directly like providing their like private information, which like clicks can be assumed as a private information. And this should be also like less noisy than the clicks. The relevance assessments have 3 values, so the website can be either not relevant, it can be somehow relevant, or highly relevant. So 2 is the highest value, 0 is not relevant at all. For the documents in the collection were created in 2 ways. So one is that we wanted to include documents which were displayed for the queries in the search engine results. So when we have a query, let's say chapeau, and there were like 10 different documents displayed in the results set by Qwant, then we would like to include this into the collection. So they should also hopefully contain something on which the user clicked. And then we are also sampling some documents which are randomly selected from the Qwant index. So we are actually selecting around 1,000 documents per topic. So for each topic we are adding 100,000 documents selected randomly. The documents were actually both the queries and documents were cleaned, and we were trying to remove the spam as much as possible. And I think this is something which changed against the last year. The spam filter looked to be stronger this year. We are providing the documents or whole collection in the 2 formats. One should be track format, which can be directly used by Terrier information retrieval system, for example. One should be like JSON format, which should be, for example, possible to use by Answerini and Pyserini and this kind of framework. So it should be quite easy to run the baseline. Here is just an example of two documents and their translations. So just to get some information about the quality and maybe what to expect. So this is the query airport Bordeaux. And the translation actually was not, the first translation was actually not correct in this case. It was only airport. So yep, the translations can sometimes, especially the first translation can sometimes be correct, but there might be some errors. We were not doing any kind of processing of the queries after they were translated, so the translations might not be always correct. And this is example of the highly relevant document. So most probably this is the official website of the Bordeaux airport. And this is an example of the non-relevant document. So this is some kind of information about the parking near the airport. So you can see that there are like lots of different information which were contained on the website, like when it was published, the menu from the top menu, or so there are like it's not always the very clear text. It might be also this kind of different texts which appear on the website. For the train and test sets, it looks a little bit differently than last year. So this year we are, as said, we are using 2023 collection, and it's larger than what we used last year. So we are using around 2 million of web pages as a train set this year. But what's the biggest difference is that we are using less filtering on the queries this year. So we are using 30,000 of queries with corresponding of 130,000 of assessments. And also the distribution of the assessments is quite different. So around 20% of the assessments are actually marked as highly relevant this year. Comparing the last year, it was only few hundreds of queries. With much smaller number of relevance assessments. So just be careful that if you are like working also or looking in the into last year's collection, then the distributions, especially of the relevance, might be very different. For the evaluation, we are interested in two things: whether the system is performing well in general, and also what's the relative difference between the performances of the systems between different collections. So we are going to use some standard measures like NDCG on the different test sets, and also we are going to calculate the NDCG drop before the different test sets. So a little bit more practical information about the participation. So for the registration, you can use the CLEF website, and there is still some time to be able to register for this. For the data download, I think most probably, I think it was like still a little bit in discussion, but most probably we will be going to use again the Lindat website, which was also used last year. And here you can find the information about the collection, and on the very bottom there is this button to download the file. When you are downloading the file, you need to sign in. If you are from the University of Padua, then it should be directly to find University of Padua there. If your university, if you are coming from different company or university which is not in the list, it still should be able to possible to download the collection, but you will need to register first. So in your if you are coming from University of Padua, you should be able then to use your Padua registration credentials to be able to get into Lindat and then download the collection. Regarding the submissions, to be able to calculate the differences between the LAC 5 and LAC 7 queries, we need participants to be able to to submit the results on both of these collections. So when you are doing the submission, you need to submit on two different collections. And together with the submission and this should be the same system. So the same system should be run on the LongEval and LongEval queries, and then the results should be submitted. And together with these submissions, the participants should also provide the description of the system. So the LongEval, LongEval, and description is like one should correspond to the same system, and that's like one submission, and you are able to do the up to 5 different system submissions. Each system then should be packed in a single zipped file. So you will have 3 files there. One is the LongEval output, then LongEval output, and then the run description. And file names should look like this. So there is first there will be a team name, then there will be the system name, and then there will be the appendix or suffix which corresponds to the file name. So it can be either L5, L7, or meta, which contains the run description. So for example, if your team is called UGA and your system is called BM25, and this is the submission on the LongEval dataset, the file name will should look like this: UGA_BM25.L5, and the submissions will be in standard track format. So that's taking maximally 1,000 documents per query into account. The submissions will be done using Git. So again, if you're a student from Padua, then the repositories which you are using for your class will be used for this. If you are different, if you are not participating in this within the class, we will create the repository for you, and you will use that for submitting your results. So I hope that we are really close to publishing the train data, and also we would like to publish the test data also during the April. Then during the May there should be the submissions of the participants, and then you are required to write the paper about the submissions, so explaining what you have done, what worked and what didn't. Then we would like to evaluate the results in June, and in July there will be like final camera ready deadline for the submissions. And finally, the conference will take place in Grenoble this year, and it will be like in September. You can of course find more information about the task on our website, and we will also try to inform the participants when the data will be released. So we'll try to also send a message when the data are released. So few remarks about like maybe some ideas on what can you try out this year. So this is the second year of the task. So in 2023, the collection looked a little bit differently. We were using the data from 2022, and there were 2 test sets again, and there was like one train set which was split on the train collection and held out collection, which was also used for testing. And just for curiosity, there's actually quite large overlap between the documents which are used in all the test sets. So it's even up till 97%. So these are, of course, data from 2023. So it might be there is a larger time difference this year between the training and test data. So there might be like a little bit less overlap, but we still assume that there will be some kind of overlap. And for the queries, it's the overlap is around 20%. And yes, so this kind of information actually would like to aim at using this kind of information. This information were not used by any participant in the last year, but this is a real life scenario with which we are working with. So you can use this information that there are like quite large overlaps between the collections, also probably this year. These are the this is comparison of different kind of models which were submitted to the task and their performance. So the green systems are some systems which use some kind of neural model. Yellow systems did not use the neural model. So you can see that there were not so many systems or submissions which used neural models, but the ones which are like scoring the best were actually the neural models. This is a comparison of whether it's the submission is consisting of a single system, so that's the orange one, or whether the submission is consisting of multiple systems combined. And I think this is quite surprising because the combination usually looks the best or works the best, like outperforms a single system. And here we are not having so many submissions which contain the combination, and also they don't perform so well. So maybe this is something to look at also this year, whether you can get it performing better, like if you can get the combination performing better this year. And this is a comparison of the systems which use English data, so that's in red, versus French data, which are in blue, and the purple use the both French and English, so it's some kind of combination of both. And you can see that the French data are actually performing better than the English, so there is probably some kind of noise. But again, I can expect that some kind of combination, if used like properly, can actually lead to the better results. So, yep, some ideas for this year. You can make use of the information that there are like overlaps between especially the document collection, but also in the query collection. You are even allowed to use like manual interventions, but this needs to be clearly marked in the submission. So there will be also some questionnaire marking whether you maybe did some manipulation with the data. So this is possible, but this needs to be clearly marked because we don't want to be unfair against the submissions which are fully automatic. Also, if you use some kind of work with the overlaps, that's of course, as I said, it's allowed, but this should be also always very clearly marked in the description, so that we are not doing some unfair comparison of different approaches. Yeah, I would like to also encourage you to use the larger training data. So what we are interested in is how the fine-tuned models and performance of the fine-tuned models drops across the time, which again, nobody from the participants used in the 2023. So I think this is a nice idea to try it out. So fine-tuning your models on the training data. Also, the training data are much larger this year than in the last year. There were some models which were using large language models last year, generative large language models, but I assume that during the last year the popularity even grows, so there might be more submissions using generative large language models in different ways. We didn't have the MBEST translations last year, so you are welcome to use MBEST translations this year. And as I said, it was a little bit surprising that the mixture of the models didn't perform so well last year, so you might try to look at that as well. So one last thing which I wanted to mention today is these manual assessments of the relevance. So within the class, you can sign up for doing some relevance assessments for some extra bonus to get in your class. And we are having the relevance assessments which are coming from the CLEF model, but of course this can contain some noise. So we would like to compare this to the manual relevance judgments. So we would need first to collect the manual relevance judgments from the people, and then we can compare the results using both. So for this, we are again using this software called DocTech. So you will get assigned server to which you can sign in. So you will first need to register using sign in, and then you can use your credentials there. Then this is the main interface, so you'll find the topics. So these are the queries, and there is a title. So that's pretty much the query. We are not using the description in this case, so you only need to look at the title. And then there are documents, so this is the content of the document. So we need to compare the title of the topic versus the document content, and tell us whether this looks relevant for you or not. And you first click on the label, and you get, actually there will be 4 options. It's relevant, not relevant, partial relevant, and there is also option I don't know. So you will get assigned different topics on different servers, and then we will ask you to go through all the documents for that topic. So regarding the how to judge the relevance of the document, basically you need to think about it that you are the user of the web search engine. You are searching for this query and you found this document. So would you stop your search in this case when you did you find the information which you were thinking about? And was this search successful? So if yes, then you can mark this as relevant. If you would just continue searching and you didn't find any information which was somehow interesting for you, then it's not relevant. And if you would continue searching, but there was some information relevant for you, then it's partially relevant. There is also option I don't know, but this should be only used in some exceptional cases. For example, if you are not able to do the assessments, maybe the file is in different language. So there might be these kind of cases. So in that case, yeah, you can mark that you are not really sure about this. And this is, of course, teamwork. So I would like to thank my colleagues who are working on this, especially my colleagues from Vienna are creating and preparing the collection this year. Yeah, so this is a very large group work. And yeah, if you have any questions, you can of course write us, or you can check out our website. And also, I'm happy to take the questions now. So yeah.
Thank you very much, Petra. Any questions? Yes.
Just to be sure around the connection between the work that we're doing for LongEval and Petra. So we can submit our system image here if we want kind of first assessment of our system before submitting our actual runs to LongEval.
So you submit to Tira because in this way it is containerized, it is reproducible, and on the training data they have available already on Tira, you can get the automatic scoring by Tira, which you can do yourself just calling track-eval on the files, on your run and on the URLs. For the submission to the official submission to LongEval, you put the files also in the runs folder. I think I have called it like this in your repo, and Petra and the other organizers will pull those runs from your Git repository. You then make the corresponding submission in Tira so that is archived and is also available for someone else to reuse and to rerun.
Okay, and the run files just a practical question. What these files, what the extensions, what format should they have?
the track eval format we have seen, you already have the code for generating that kind of files, is exactly that thing. The only difference is that in this case, you have much more queries than the 50 or 250 queries we have working with. So they will be bigger files. Any other questions for Petra? I have one, Petra. How do you classify or link queries to topics?
Basically it's just whether the query contains the topic name. So the topic name are very general. So if the query contains the topic names, we just say it's relevant.
Okay.
So it's very very simple.
Is everything clear, guys? Because this is the right moment if you have some doubts about the setup, what you are expected to do, etc. Also for the relevance assessment, those of you who will volunteer, then they will have to use this doc tag interface and follow the rules.
And we will send the instructions for that.
Yeah. Yeah.
Just one more time, just to be sure. So to get balance, we can both submit our system to Tira and you use ourselves the code to generate the track runs.
Your code has to generate the track runs in any case. Okay.
But then we can also load the system to Tira so that it is another method of clearing the run files.
I mean, Tira will take your run files and score them. So, Petra, you have been so clear that no more questions are needed.
Yeah, no problem to send the questions if something comes up.
Okay. Thank you very much for your time, and hope that everything will go well with LongEval and our participation.
Yeah, thank you very much for the invitation.
Have a nice day. Bye-bye.
You too. Bye-bye.
So let's stop the streaming here.